Hey everybody, this is Austin and welcome back to my channel. Last video we created a parametric fretboard in Fusion 360 from start to finish, and this gave us a huge amount of versatility in our designs and should have been a real time saver. However, many people reported to me that while replicating my results at home, Fusion kept crashing while entering the fret dimensions or even just looking at the user parameters button. Well, after looking into this with members of my Discord to understand why this was happening, we were able to come up with a really simple solution to this issue, and honestly, I feel like an apology is in order. When developing this design, I neglected to consider how Fusion would respond to calculations that were dependent upon a large series of other dependent calculations. The cyclical nature of this method meant that each time a fret referenced the previous fret, the calculation weight on Fusion increased exponentially, resulting in Fusion crawling to its knees by the time you've entered 48 of these dimensions. So I sincerely apologize for giving you information that may have crippled your computer's performance and, ironically, eliminating the time-saving benefit of this design. I also received a lot of questions about incorporating compound radius options, consistent edge thickness, and even parametrically controlling the vertical fret. So that's the plan for today. We're going to go ahead and first of all fix my mistake, and then see if we can squeeze out even a little bit more versatility out of this design. So let's dig right in. Okay, so jumping into Fusion, let's talk about what this actual issue was and how we're going to solve it. Now, I'm not going to be remodeling the entire fretboard from scratch, meaning I'm not going to be resketching this. That process is identical to my first video, so if you haven't done this before, go back to that video first and then come back here for some updates. But we are going to be adding some additional features here, so we're actually going to be deleting our timeline up to that original sketch, and we're going to be recreating it from there. Now, if we go back into the first sketch, let's talk about what actually happened. So the way we laid out the math in the first video, if I open up the user parameters tab, is we did the low E scale length minus low E scale length divided by the 12th root of 2 to get our distance from the nut to the first fret on the low E side. And we did the exact same thing for the distance from the nut to the first fret on the high E side. And we used the multiplier that we talked about in the first video to go ahead and distance between each fret. And so what that looked like is our first fret just referenced that formula, which was low E, fret 1. And then our second fret referenced that dimension times that multiplier. And our third fret referenced this dimension times that multiplier, etc. And so what ended up actually happening is this is one calculation, and then this one now has to solve 2, and this one now has to solve 3, and 4, and 5, etc. And if you actually do the math, by the time you get to 48 dimensions, because we've got 24 on each side, that's over 300 separate calculations that Fusion has to do in order to calculate this sketch, which is why the sketch kept breaking or freezing on you. And so what we need to do is we need to actually simplify that formula, so that way we're not creating a dependency problem where each fret is dependent on the fret that came before it. And so we need each one of these to be able to calculate independently of each other. So what we're going to do is we're going to basically keep most of this, but we're going to change how we apply the dependency. And everything is going to be dependent on one fret. The first fret, which references our user parameter. It's not going to be dependent on a large chain of frets. So in this case, you can see what I did here is I did D16 times multiplier. And then on this fret, I did D17, which is this one, times multiplier. So the way we're going to change this is we are going to delete the D16, and we're going to change this to low E fret 1, which is our user parameter, times the multiplier. Now you could leave this at this one, but just for consistency's sake, this will make sense in a second. We're going to say to the power of 1. Now that is going to be the same number, but if I hit enter, that gives us the exact same value. And so on this one, all we need to do is do the exact same thing. We're going to delete this, and instead of referencing the fret that came before it, we're going to reference the first fret. And so we're going to say low E fret 1 times multiplier. And in this case, instead of to the power of 1, we're going to say to the power of 2. And so you can see what's going to happen here is as we go down this chain, we're going to have the user parameter, and then the user parameter times the multiplier to the power of 1, user parameter times the multiplier to the power of 2, and then I've already applied this to the rest of this design, so my design stops freezing on me. But this one would be low E fret 1 times multiplier to the power of 3, to the power of 4, 5, 6, 7, etc. So you get the point. So effectively what we're doing is we're really shortening that calculation chain that Fusion has to do, because each dimension is only one calculation away from that user parameter, not, 24 or 48 or 200 or 300 steps away from that original user parameter to figure out its position in space. So the high E side is literally no different. So you start with your high E fret 1, and then you go to high E fret 1 to the power of 1, to the power of 2, 3, 4, 5, etc. That will break that chain on all of these dimensions, and Fusion will be much happier with you. So I'm not going to do all of that live with you guys. I've already applied it to this model so we can save time and move on to the other things we're going to be doing with this design. So before we go ahead and loft or extrude anything, I want to give a quick shout out to a Discord member of mine by the name of Matt Jacobs, who came up with a very clever and simple way of parametrically controlling which fret is vertical without the need of a vertical constraint. Because what I did in my design is I just picked which fret I wanted and then assigned a vertical constraint to that, which locked that in. Now, unfortunately, if you wanted to change that later on, you'd have to reopen that sketch, delete that vertical constraint, and then come back in and apply it to whichever fret you want. But he actually came up with a way to be able to just type in which fret you want to be vertical and have the entire sketch update. That's very cool, a very nice addition to this design. So let me show you how to do it. It's actually quite simple. So we're going to add a user parameter called vertical fret. And we don't want it to have any units. We don't want it to be inches or millimeters. We just want it to be a value, like a value of 24 for the 24th fret or 7 for the 7th fret. And let's just go ahead and put 12 for now. And let's add it to our favorites so that way we can hide it from the rest of the formulas. And that's all we have to do in the user parameters tab to do this. So now we need to add it to our sketch. And the way this works is you create a point anywhere, doesn't matter where you put it, anywhere along each edge. So let me put it here and here, for example. Now you'll notice I didn't make that coincident, and these need to be coincident to that line. So I'm going to apply a coincident constraint, and this one was the same thing. Apply a coincident constraint to that line. Now, the other thing that is required in this is each one of these has to be vertical to each other. So if I select both, I can come up here and hit vertical. Now they are going to remain vertical to each other no matter where I drag it along this. Now you'll notice as I drag this along, this is rotating on us, which is good. That's what we want it to do. So now we just need to dimension between the nut and this point on each side of the fretboard in order to tell the fretboard how to rotate. And so we're just going to write another formula, very simple or very similar to how we calculated our low E fret 1 position. So I'm going to add a dimension from here to here, and we're going to write out our formula. So I'm going to say low E scale length minus parentheses low E scale length divided by parentheses 2 to the power parentheses of, instead of 1 divided by 12 like we did before, we're going to say vertical fret divided by 12, and then enough parentheses to close out that expression. Hit enter, and you'll notice that that point has now automatically jumped to the 12th fret position, that exact same spot. Now you'll notice the bottom one hasn't yet because we also need to apply that same dimension or formula to the other side. So let's go ahead and copy this whole formula right here. And for now, I'm just going to paste that in here. So dimension from that point to the nut. And we're going to paste that in here and hit enter just for now. Now, that's not correct at the moment because that's not vertical. So the only thing we need to change is change this to high E scale length, and this one to high E scale length as well. Right there, exact same formula, just high E instead of low E. And now if we hit enter, you might not have noticed, but everything has now snapped to vertical. So let's go ahead and check this real quick, and let's type in which fret we want to be vertical. So if I open up the user parameters and I say I want the first fret to be my vertical fret. Now you'll notice that has automatically moved to the first fret, but it's kind of hard to tell that this is working because we only have a single scale length. So let me change this to 24, and let me change this to 25.5, a pretty standard, kind of scale length setup. Now you'll notice that our first fret is vertical. So let me type fret 2. That has now moved and fret 2 has jumped over. So let me try fret 12. There you go. So you can see that that has now moved to the correct location and that fret is vertical. So that is insanely simple and such a cool addition to this design. So Matt, I just want to give you another shout out and say thank you for developing that for us. That's great. So let's go ahead and move on because we've already broken the calculation loop and added some vertical fret functionality. And now we're ready to go ahead and build out the fretboard. So go ahead and close that sketch and re-show it. And in the previous design, what I did was I just simply extruded this body up like so, and then I cut a radius through it. Now that worked very well for me because I was only using a single radius, but that doesn't work so well when you're trying to do a compound radius. So we actually need to create two sketches, one on each end of the fretboard with our different radius profiles and find a way to either loft or extrude or sweep or anything between them in order to create our compound radius. So let me undo that. And we need to generate some planes on each side and find a way to reference where that line, where these two lines would be in that plane. So let's go ahead and create a offset plane from the center, and we're going to do the nut or the heel side first and then the nut. And let's drag it this way, and we're going to say to object, and we're going to select the point at the furthest end on the heel side of the low E scale length. So we're going to say that point right there and hit OK. And we're going to do the exact same thing for the nut. We're going to drag it this way and say to object, this furthest point of the low E side on the nut. Now, the reason why I'm doing it on the low E side rather than the high E side is because the low E side is almost always going to be the side that's going to be further out. I don't know of anybody who currently or previously has created a scale length where the higher strings are actually at a longer scale length, and it doesn't really make sense. So we're pretty safe to do it this way in 99% of situations. So I'm going to hit OK, and we can go ahead and sketch on this heel side plane. And so you'll notice that I don't have a good reference here on where this line should be. Now I could simply project it, but if I hit P on my keyboard, you'll notice I get a line here. What we actually want is a point where this line intersects that plane. Luckily, there's a project tool for that. So we go create, project include, intersect, and we can just select these two lines right here, and that will give us the point of where those two lines intersect our plane. Hit OK, and that is where we can now sketch on. So let's hide our first sketch. Now, I generally like to draw this with two lines going up like this. Let me do this quickly. And an arc going between them. Because I generally don't like to draw full circles or anything if it's not necessary. So what we're going to do instead is I'm actually going to draw a circle because this will make what is happening with a compound radius significantly easier to explain. So I'm going to draw a circle up, and I'm going to draw a circle on the other one. So let's go ahead and create a sketch over here. And I'm going to draw a circle as well. Now I'm going to make that one a smaller circle for the time being and hit OK. And let's go back to here and make this a larger circle. There we go. So this will make what a compound radius does easier to explain, because on one end of the fretboard, you have a pretty large radius, and on the other end of the fretboard, you have a smaller radius. And so what you're doing is, if you imagine that you lofted between these two, you'd be creating a cone like this. And so that is actually what the base shape of our fretboard radius looks like. And you can imagine we just cut our fretboard out of, if you had a block that was the shape of this cone, we basically cut it out of that shape. And that's actually a very good way to do this. And so that's actually how we're going to model this. So what we're going to do is we're going to go back to that first sketch. And what we're going to do is we're going to hide the first one and then drag a line up on each one of these points. Like that, we're going to make these construction lines. And we're going to drag a line between them. Now the center point of this and the center point and this right here may not be actually the same point, because the fretboard gets angled and gets wider and tapered near the heel. And so it's actually useful to just draw a center line like this and make it midpoint to this line rather than making it coincident to this point. And it might be obvious if I show you in a second. So as I zoom in, you'll notice that the midpoint of that line is not coincident to the origin point of this plane. So be conscious of that and don't draw it to the origin point of this plane. Otherwise, you might create some results for yourself that you're not happy with. And let's make these two equal to each other. And let's make this point coincident to that circle. And let's make that a construction line as well. What this is going to do is this is going to allow us to basically visualize what our profile is going to look like. So we need to give this a dimension of fretboard thickness, the same parameter we created in the first video. That's going to establish the highest point at the peak of the fretboard. And we need to be able to define what the radius is on the backside here. So I'm going to go ahead and create a diameter dimension for the time being and just hit enter. And if you click on that dimension and you right click it, you can change this. Oh, sorry. Let me back out of the dimension tool here. Click on that dimension, right click it. You can say toggle radius, and that will allow you to dimension the radius of this circle rather than the diameter. And now I'm going to say fretboard radius heel as my parametric value. And right now that is set to 7 inches. And so that's what it showed up as. So let's go ahead and make this something larger for now. Let's make it 15 inches. And we're going to do something very similar to the front side, but we're going to have to add something to our original sketch, which I'll show you in a second. So that one is fully defined. And let's go to this other sketch. Now you'll notice that this line right here doesn't intersect this plane. And so we actually need something to tell us where that would intersect this plane, because this line is not horizontal. So we can't just simply project that point to here, because that is tapered, so it would angle in this way as it comes towards this plane. So what we can do is we can go back to our very first sketch and create a reference point for us of where that would intersect this plane. So I'm going to add a point just right here in the middle. And we're going to say this point is coincident to this line, but we still want to be able to move it. And you'll notice I can move it off of that line and then make it vertical to that point. Now what that does is that basically if I drew a collinear line, so if I did this right here, just for example, if I drew a collinear line out, you'll notice that that eventually would reach that point and it's tapered from this horizontal dimension. So we can rest assured that that's actually accurate. Go ahead and hit finish. And now we have a point of where that fretboard would hit that plane. So let's go back into here and we can just simply project that point. And now we have the same 2 points to start with. And now we can go ahead and do our construction lines. So let me project in that point as well. And we're going to draw a construction line, a vertical one up to there. Do another one from here to here. And another one from across the bottom, just like we did before. And let's make sure all these are construction for now. And we're also going to draw a center line. Again, we're not going to snap it to the origin point. We're going to snap it to the midpoint of this line. And you'll notice those are offset from each other as well. And then we want to make this coincident to that circle and make that a construction line as well. Okay, so now we're set up to do what we did before, but here's where compound radiuses get really tricky, and you have a lot of options of how you want your fretboard to be constructed. So let's go ahead and start with the simplest version, which is identical to how we defined the circle on the backside of the heel. So we're going to give this a vertical dimension of fretboard thickness, and we're going to make these two equal to each other. And then we're going to define our radius. So just hit enter and then right click that and say toggle radius, and we will say fretboard radius nut. So right now we have a 7-inch radius at the nut, and I believe it was a 15-inch radius at the heel. So if we look at it from this way, and let's go ahead and change this real quick to be identical to each other. So fretboard radius nut will be 15 inches. So you'll notice that we have two circles that are directly on top of each other, and basically what we have is a cylinder rather than a cone. So if you made these identical radius, you could have a single radius design. And so it would be consistent all the way, consistent thickness in the middle all the way from the front to the end. But what you'll notice is that there is a slight taper from here to here, right? So if I drag that out, and that is exactly what happened in my previous design, where as we decreased that radius, so let's go ahead and go back to our parameters, and let's say 7 inches, and let's say 7 inches here as well. The thickness at the heel side of the fretboard got significantly smaller the smaller the radius you went down or the wider you made the fretboard. So let's make the heel width, let's say 4 inches. You'll notice at that size, that actually cuts through where we need it to, and so you actually have, it's not, the radius isn't large enough to support that. And so there's a way a lot of people tend to do this, is they tend to make the edge of the fretboard the exact same thickness all the way down the side of the fretboard. And there's an easy way to do that. So let's go back and change these real quick, back to, let's say 2.25. And let's change this to 15 and 12, for example. Okay, and let's look at it from this front view again. So these are no longer a consistent radius. They are a cone rather than a cylinder. And what we can do is we basically need this point and this point to be horizontal to each other. And so what we actually have to do is either delete the radius or delete this vertical dimension. And I'll show you what happens when you do either. So let's start with deleting this vertical dimension and allowing our circle to lower and get thinner at the center of the fretboard at the nut rather than the heel. So all we have to do is project in, let's say we project in that point right there. Now what we can do is make this point horizontal to that point. And that basically what that allows us to do is drag a horizontal line all the way down the fretboard, which creates a consistent thickness at the edge of the fretboard at the cost of a consistent thickness at the center of the fretboard. Now, it's not a big problem with the dimensions we gave it. It's a very small change. But as you change this dimension, so let's say like 15 inches here, that becomes considerably larger taper. Or if we make this significantly larger on the back side, so let's say 20 inches, it becomes narrower. Or if I make the gap between them essentially larger, so let's say 7 inches here, you can see that you run into problems where things start to get a little haywire. And actually in this case, the center of the nut at the center of the fretboard at the nut is thicker than in the center of the fretboard at the heel. So you actually have a pretty narrow window of how narrow that radius can be, or how small that radius can be before you run into issues. So let's try 15, 14. Eventually that's going to get thicker. So let's go 13, 12. And at around 12, in fact, actually at 12, we're already taller at the nut than we are at the heel. And so that is one limiting constraint. Now, another way you could tackle this is, let me undo these real quick, and let's keep the fretboard thickness, but you could just delete the radius. So if you want to have a consistent thickness at the center of your fretboard, and you want to have a consistent thickness at the side of your fretboard, and have a compound radius, there's only one radius that can achieve all three of those constraints. And so you can allow Fusion to define that for you, right? You can no longer define your radius at that point. So in this case, what we have is we have the same thickness, but all we have to do is make this horizontal to that point again. So let's project in that point again, because I lost it. Make those two horizontal to each other. And you'll notice this circle is fully defined. Can't define the radius because there's only one radius that touches through all three of those points. And so let's go ahead and measure that and see what that looks like. So this one was that one was a 15-inch radius. And this one is a 8.93639-inch radius. And so if you're doing this with a CNC, that's totally fine, right? Your CNC can cut that. If you're trying to sand this manually, that becomes a bit of a problem. So I actually really like this method if you're doing it with a CNC, but if you want a little bit more control, then you're going to have to play around with your numbers to get a radius that fits within the window of what your design can accept. And so that is kind of a big challenge when it comes to designing these. So let's go ahead and redefine our radius and we will move on from there. So I'm going to delete that height. And what we're going to do is we're going to toggle this and then right click it, toggle radius, and we'll say fretboard radius nut. And we're going to leave this at a consistent spine height right here, or edge height of the fretboard. I keep calling it spine, but at the cost of a little bit of thickness from the nut to the heel. And so let's go ahead and change this to 7.5 at the nut, and let's change this to 12 at the heel. Yes, and so they're going to be pretty similar, but slightly different. I'm going to go ahead and hit OK. And now let's go ahead and loft between these. So we'll close out this sketch and we will say create loft between here and here to create our cone. Hit OK. That's all you have to do for the loft. And now we can simply extrude. Let's hide this real quick. We can simply extrude this surface up as if we're going to cut it. And we're just going to say all. So it stops at the edge of that fretboard. And now all we want to do is we want to retain everything that's in red, right? We don't want to actually cut. So if I just hit OK doing that, it's going to cut that shape out of there, but we don't need that. We just want to retain only where those two intersect each other. And so I can change this from a cut to intersect, and you'll notice everything else has disappeared except where those two features intersect each other. So hit OK, and we've already got our fretboard with a compound radius. So if I select this surface right here, you can see that there is a change in the radius from the front to the rear. And so that is done. And now we can fully define, or not fully define, we can come in and change these dimensions again. So we can say 15-inch radius, 20-inch radius, and you'll notice some things get a little weird as you start changing things around. So let's go back to 12. And let's say 12. And you'll notice you kind of have a concentric circle, right? It's a cylinder, but you've tapered your cylinder down a little bit, so it's a little bit thinner at the nut and the heel. And we'll just say like a 10-inch radius and a 15-inch radius. And there you go. So you've got your compound radius. Again, you guys are going to have to play around with these numbers and how you constrain that nut sketch in order to get the results that you want. So let's go ahead and close that out. And let's talk about how we're going to cut the fret slots or not cut the fret slots. So just like in the previous video, what we're going to do is we're going to project in all the lines from that original sketch, all the fret lines. But we need to project them into a plane that is higher than the fretboard body. So we're going to go ahead and create an offset plane from this plane right here. And we're going to make it go up fretboard thickness times 2. Hit OK. That way we will always have a plane that is taller than the thickness of our fretboard. And let's go ahead and sketch on that plane. Hide our body. And we're just going to project in all of these construction lines. Apologize, I'll try to do this quickly. Almost there. Okay, project those in. Hit P on your keyboard, enter, and now we've got all those there. And what we did before is let's hide our sketches. We also projected in the surface lines here from the body, but you can also project in the sketch lines. I just preferred doing it that way, but we can go ahead and project these as well. And let's hide that original sketch and the body. We'll select everything, and we will make those construction lines. And what we did in the previous video, we're going to do the same thing, is we're going to go ahead and say offset. We're going to offset these 2 lines. So this one, and we're going to say, just hit enter for now. And then we'll do this one as well. Enter for now. And let's check these. These are both positive values. And if we drag it, let's do like negative 0.375. That goes to the inside, negative 0.375. Yes, that goes to the inside. So we're good there. So now we're just going to make this tang offset. Same user parameter we did on the first video. And tang offset on this one as well. Okay, and just like before, what we're going to do is we're just going to draw a few lines connecting that point where these sketches intersect each other, and that will allow us to do a thin extrude, just like we did in the first video. So bear with me real quick while I draw these out. Okay, thank you for bearing with me on that. And now we can go ahead and select these 2 lines and make these construction as well. And we can go over to solid extrude, and let's show our body, and then go to thin extrude and click, excuse me. Actually, you'll just select all of those lines real quick. Let me cancel that. Go back to extrude, thin extrude, and select all of those lines, show our body, and we can now cut those down into here. Now, here's a challenge that I ran into when developing this 4 compound radius. So in my original video, what I did was I said extent type to object that surface. And then I did a negative offset. So we'll do negative offset of minus tang depth. And that actually worked in this case because we're inside the extent of the fretboard and we maintained our radius. Now watch what happens when I change our offset to a positive value. So if I come over here and go to tang offset and I change this to, let's say, 0.25. Let me try that again. Yes, you're noticing what happened is the extrude broke. And if I double click this, it can no longer use that as a reference. And I'm not exactly sure why that is the case, but I suspect that it has to do that Fusion doesn't like extruding 2 surfaces when they've been cut in multiple axes at the same time. I ran into this in my splines are overrated issue where I tried to, or not issue, video, where I tried to emboss a splined sketch onto a swept body that had been cut in 2 different directions. I ended up having to do a flat extrude. And so the only extrude type that works for both situations where you have it inside the fret boundary, or not the fretboard boundary, or outside the fretboard boundary, is a straight cut. So if I drag it down, that means you have a flat fret slot bottom rather than a curved one. That will always work. But when you're referencing the surface, sometimes it will break the sketch on you. Now, this is the reason why I mentioned right at the start of this that maybe we don't cut the fret slots, because the fret slots aren't really that useful for us. They are more of a visual cue, or not a visual cue, but just a visual thing for us, so that way we can develop better renders or things like that. When you're actually doing the cam for fretboards on your CNC, they're not particularly useful. And I will show you guys how to create a different sketch that you can use to do the cam for your fretboard. But if you want to have this feature where you can define whether your frets are hidden tang or through tang, then you will have to, with a compound radius fretboard, you will have to do a flat bottom fret. I haven't been able to solve it otherwise. The only time the curved slot fret works is when you're doing a hidden tang. So the way to do this and still retain that functionality is to not reference that surface, but instead we can still say to object, but we can say to object this point right here. And we can still go down negative tang depth. So that way the depth of this remains the same all the way around. And I can hit OK, and we get our fret slots, and I can come back in and change that offset to a negative value. So like negative 0.125, and we can get both functionality out of it, but at the cost of having a flat fret bottom rather than a curved one. Now, one thing I forgot to change in here is we have the wall thickness of tang width, and we want the location to be the center, and that's good. So there we go. So now we have those fret slots. So what I'm going to do now is, that is an optional feature. You don't have to have those, like I mentioned, because they're not particularly useful in the cam. So we can actually just suppress that feature. So if we come over here, let's actually just suppress all three of those. Right there, right click, suppress features. That will disable those features from the timeline, and we can only show them when we want to do renders or something like that. But while we're actually trying to build the guitar or trying to do any cam work, a better solution is to do something else. So what we can just do is sketch on any surface. It doesn't matter because it's going to be a 3D sketch. So we'll just sketch on that top plane. And then I can go create, project include, project to surface. Now if I project to surface and I show the original sketch, and let's hide the body, then I can just select, body, we need to select that top face. Now we can hide the body. And curves, we're going to say these fret sketch lines. And what those are going to do is those are going to project, but they're going to project at the curve of that surface. So let's go ahead and do that all the way around, like so. Almost there. Okay. And then we can just hit OK and finish our sketch. Those are the sketch lines that you're going to need when you do the cam for this, because you can just do a trace toolpath and cut it down to a very specific depth. But what you can do is if you want to show that for rendering purposes, you can come back to these three, right click and unsuppress those features and show them just for that render. Okay, so the last thing we're going to do, and then get you guys out of here, is we're going to go ahead and just double check all of our results, make sure nothing in our timeline breaks for any reason, and we should be good to go. So we're going to change this to a single scale length, 24 by 24. Yes, that still works. Let's change that back to like 30. Okay, and let's check while we're here the vertical fret that Matt provided for us. And let's do like the 7th fret or the 1st fret. And let's try the 24th fret. Yes, all of that seems to be working as expected, so I'll change it to the 7th for now. And let's go back to a 25.5 inch scale length. And let's change our nut width to 2 inches or 1 inch. That's all working just fine. So we'll go 1.75. Our heel width, let's change it to 3 inches. And let's see, yes, we are still maintaining a edge of our fretboard thickness. So we're good there, even though we made the edge of the fretboard wider. So let's go like 4 inches. We're not running into that issue that we did before where the edge of the fretboard gets thinner at the heel rather than the nut. So that is a nice solution to that. So we'll go ahead and do 2.25. And let's change our fretboard thickness to like 0.5. Yes, that's still working. Let's do 1 or 0.125. Yes, we are good there, so I'm happy. So back to 0.25. Let's change our fretboard radius on the nut side to something a little bit larger. So let's go 12, which is going to lower it on the front side. And let's change our heel radius to like 17, which is going to lower it on the back side, effectively raising the front side up. And yes, we're totally good there. Everything seems to be working. Let's change our tang depth. Actually, let's change our offset first. So 0.25 as a positive value. And let's see, our depth is 0.07. So let's go 0.125. Yep, that's working. Our tang width, let's try 0.0625. Yes, that's still working. 0.023. And our fretboard radius heel, yep, okay. So this is now our completed fretboard, and I'm pretty happy with the results we got. This design is a really great example of why we need to pay attention to our modeling workflow and be mindful of how Fusion will respond when rebuilding the timeline. I was so excited to share my results in the first video that unfortunately I neglected to consider how the compounding fret dimensions would create problems for users. So again, I sincerely apologize for providing you with instructions that may have crashed Fusion or rendered your model unusable. But this mistake also provided me a good opportunity to reevaluate the design, and with the help of your feedback, I was able to improve it in the process. So I just want to say thank you to everybody who took the time to leave comments or message me with issues you encountered or ideas for improvement. And for that reason, this model will now be available for download on grabcad.com for free. If you'd like to support my channel or help me to continue to provide detailed tutorials like this, or simply want to download any model featured in my videos, you can find me at patreon.com/Austin Shaner. If you'd like to request a topic for this channel or join a growing community of talented designers, luthiers, and engineers from all over the world, you can join our Discord server. Links will be in the description below. But thank you all for coming. This is Austin, signing out.